Alright guys, so in our next video we are going to look at what happens when we start dealing with some boundaries that start changing. Some intervals start changing, the functions start changing as you kind of go through the flow of the graph. The goal of this video is to be able to find area of enclosed intersections using what we call as sub-regions. So I have a graph here for you to look at two different functions. The red is y equals root x. The blue is just a straight line of x minus 2. And so the goal is to find the area under these two specific curves. Alright, and so the question is going to focus on find the area of the region R in the first quadrant that is bounded above y equals root x and below by the x-axis and the line x minus 2. Okay? And so we really are trying to focus on basically the entire region enclosed all through here. So I'm going to go ahead and change colors, and I'm going to kind of show you what our goal is, and then the colors are going to change a little bit as well too. So the goal is to kind of get everything happening in this general vicinity, right? So that's really what the goal is, to find everything that's happening in here. But hopefully you're starting to notice, as I'm just kind of having some fun coloring, you're starting to notice that, technically, all right, we're not bounded by the same functions throughout, right? So think about what's kind of happening, from 0 to 2, the function y equals x minus 2 is not really existence, right? It's not really happening. There's no input from here to here, all right, from 0 to 2 in this example, right? We know that it would go down forever if we're curious about that. We want it in the first quadrant, though, is what the question says. And that's what we're focused on, is everything that's in green. And so there's no relationship from 0 to 2 from the red to the blue, to keep things simple, right? And so it's almost kind of like if there is a region split there, right? And so then we're really kind of starting to focus on this half and, of course, this half. And so we need to kind of think to ourselves, what are we utilizing for each of those? Well, again, this is kind of split up into now our two subgroups. So we can't necessarily say that this goes from 0 to 4. I mean, this point right here, and I didn't draw it great, all right, is roughly, at the point about 4, comma 2, give or take. And so we would say, well, the entire intersection happens from the interval of 0 to 4, which, yeah, it kind of does in our example, but the area of the intersection is not really existent, all right, from 0 to 2, right? You have no relationship of y equals x minus 2 from the intervals 0 to 2. The relationship is only y equals the root of x. And so the area of all of the green together is really the area of purple plus area of our baby blue that's happening in here. And so now let's think about what is the thing happening in this area. Well, in all purple areas, it's only y equals root x. It's from 0 to 2. And so what this tells us is that we are looking for the area to equal to the root from 0 to 2 of root x. So the interval, from 0 to 2 of root x dx. And then we will now add the other half of things. And now from 2 to 4, well, now from 2 to 4 becomes our area between the two curves. So now it's the root of x minus 2 all dx, right? Do we see that, guys? I hope we understand kind of where we're all coming from with this. So we're going to go ahead and find that area is equal to, in this case, don't forget, guys, it's 2/3 x to 3 halves, raise the power, divide by the power, from 0 to 2, plus, now we have 2/3. We have 2/3 x to the 3 halves. We have our x squared over 2, and we have our 2x happening in here. And so this is the entire thing of 2/3 x to the 3 halves plus x over 2 squared. And then plus 2x as well, all from 2 to 4, okay? So kind of think, oh, I'm sorry, this is supposed to be a negative in here. This is not positive, the other one's positive. So negative over there. All right, and so what we see here, guys, is that we can't assume, all right, that this is the entire thing. You've got to really analyze these graphs sometimes when they're given to you to make sure that we see where we're all coming from in this. And so kind of going through, and again, just kind of save some time, we can all do the simple basic math, and we substitute these values on in. Adding these together, we see that we end up getting 10³ units squared. All right? And so, just another way to kind of see what the difference is between all those particular areas that we could see inside of our graphs. All right. All right, guys. Nothing to follow this video because we have one that was just very similar for the last video as well too. So we're on to the next one.